live button now.
Okay, and do an announcement.
Okay, everyone. So this is the May 2022 ChicagoTIUG Users Group meeting. Welcome. And with us today is Vic, our person running the demos, and myself, Jim. Apparently Hal isn't here at the moment, but hopefully he'll be able to join us at some point. And I guess I'll mention again that the fair is supposed to be, oh, go ahead, Vic, did you need something?
No.
Okay, and I guess I will remind people that the fair is currently scheduled, I believe, for last Saturday in October, which I believe is the 29th, but more details will come.
Okay.
And I guess Vic, go ahead and.
All right. I didn't want to step on you because
Sorry.
it turns into 2 or 3 people talking over each other all the time. Well, as I announced, we're going to be getting into some programming in Basic and Extended Basic. And even though everybody has compilers that we can use that can fantastically speed up Extended Basic programs, back in the old days, you had to write good code to start with. And so Craig Miller of Miller's Graphics had come up with the Smart Programming Guide for Sprites with this fantasy cover here. And in it, he goes through quite a few different demonstration programs on writing good code, and he documents it, every line, what's going on and what each command means. So we're going to go through this page by page. I also posted a PDF of this online. Sure, loaded RXB here, do a directory of disk drive number 1. The disk is named Miller. And so the program names, to explain what's going on here, is by page number. So here's the first program, Joystick 1, and it's on page number 7. So that's the format I used for it. So Craig has a couple introductions here on proper programming structure. And I'll just go through it. With proper programming structuring, the TI-99 home computer with the Extended Basic Command module can be very powerful. Listed below are some tips that will help you save bytes and enhance the speed of your programs. Keep your variable and string variable names as short as possible, preferably 1 or 2 characters. I remember there was a program out there that would actually go through your program and scan it, and where there was a variable name, it would reduce it to 1 letter all the way through your program. If you had 20 or 30 variables, it would reduce each one from the English language name that you had typed in there down to just a letter. Keep the number of different variables and string variables to a minimum by reusing them whenever possible. Yeah, because variable names take up a lot of data. Regular variables such as A or A string run faster than subscripted variables such as A parenthesis 2, N parenthesis 2, or A string parenthesis 2 end parenthesis, which runs faster than arrayed variables, such as A parenthesis 2 comma 3 end parenthesis or A string 2 3. Always try to use full multiple statement lines. All right, that's a big thing in Extended Basic because the TI interprets each program line separately, and it's that interpretation that takes a little time. So if you can combine multiple statements into one line with the double full colon, it'll run faster. Always use the
two characters as the two-character delimiter rather than having to process an entire line.
Yeah. Excuse me. Here I'm trying to find here my wired remote controllers, because this is a joystick demonstration program. So let's get some action up on the screen. We'll plug these in. Okay, so here's a demonstration on the screen of alpha lock up. Okay, move joystick number 1 north, and you see how the command on the left changed. We'll move it west, east, south, diagonally. So this first program is a rather simple joystick tester program. Okay, another shortcut. Try to define as many characters as possible in each call character statement. Keep your go-to and go-sub statements to a minimum. And the fewer bytes in a statement, the faster it will run, is a good general rule to remember when programming. And on page 3, he has a conversion tables here to convert from graphic row to dot column as an example. Graphic times 8 minus 7 equals dot row. And he goes through graphic row, graphic column, text row, column, dot row, dot column, to graphic, does them back and forth. And he has a little glossary here at the bottom, what his shorthand means. GR means graphic row, GC means graphic column, etc. Page 4, notes. The effective dot rows are 1 through 188, dot values 189 through 256, return 24.5 through 32.875, which will be rounded up to 25 and 33, which are not valid graphic or text rows. And he has a whole bunch of different notes here, but let's get going on. Okay, so here's the first program, which is Joist 1. And the following 3 programs were written to demonstrate different ways of moving your sprites around the screen. We'll quit this program. Alright, we get the program on the screen. It can sit there for a while. So this shows different ways of moving your sprites around the screen. The first program sets your sprite in motion only when the joystick is moved. The second program will demonstrate additive motion. The longer you hold the stick in any one direction, the faster your sprite will move. To stop the sprite, you will need to cancel out the motion by holding the stick in the opposite direction. The third program moves your sprite to a new graphic row and or column each time the stick is moved. All 8 positions on the number 1 joystick are active for these examples. Okay, so we're not going to need joystick number 2, just joystick number 1 for this. Alright, so joystick number 1. Program line 100. Call clear, call screen 13, call magnify. Alright, he goes through every line. And I'm not going to do this for every program here, but just as an example for this first one, how well he documents what he's doing. Because some of this, this might be simple enough you're familiar with the Extended Basic, you can follow around. some of this stuff, his algebra and everything, gets really convoluted, and I wonder how anybody could have figured it out in the first place. But here we go. Okay, line 1, or line 100, clears the screen. Okay, call clear. Here, let me just, wish I had something to hold this little book. So call clear. Okay, call screen 13. Changes the screen color to a dark green. The third statement, call magnify 2. Set sprite to a magnification of 2. A single character made up of up to 64 dots, which occupies 4 character positions on the screen. Set sprite number 1 as character number 42. The asterisk, its color will be white, and will be placed at dot row 100 and dot column 100. The velocities were left out, so the sprite will be stationary. The next page. Okay, let's go down one line. Okay, line 110. Now that our sprite is set up on the screen, our program will only loop on this line. The first thing we do is to look for a joystick input. If the number 1 joystick is moved, then X or Y, or both, will contain -4, 0, or 4, depending on how the stick is moved. The Y variable will contain the row velocity commands, and the X variable will contain the column velocity commands of the call joist statement. The statement will place our sprite in motion according to the position of the joystick. If the joystick has not been moved, then X and Y will equal 0, and our sprite will stop. If we push the stick up, then X will equal 0 and Y will equal 4. Our sprite needs negative row velocities to move up and positive velocities to move down. So we will have to change the value of Y by placing a minus sign before it. Now when Y equals 4, negative Y will equal -4. And when Y equals -4, negative Y will equal 4. The column velocity commands do not have to be changed around, since X will contain -4 when the stick is moved left and 4 when it is moved right, and this will move our sprite in the proper direction. In order to speed our sprite up, we will multiply our X and -Y values by 4 to obtain velocities of -16, 0, or +16. If you would like to use different velocities, you can change the 4 to any positive number that is less than or equal to 31.75. A number that is higher than 31.75 will return a positive row or column velocity that is greater than 127 and will cause an error message to be generated. In this section of line 110, we will display the X and Y values from the call joist statement and the sprite velocities as you move the stick to different positions. Now we will jump back to the beginning of line 110 and do it all again. So I hope you're able to follow along with that. So that is joystick 1, 2 lines, line 100 and line 110. We'll run that again. Get joystick number 1. And there's a demo program you saw. Move the stick north, move it south, and as soon as you let go, it stops. It only moves while the stick is in motion. It does diagonals, and it shows you what commands you're getting from your joystick. So that's a nice little joystick tester. Now we'll load the next program here. On page 8, a program named Joystick 2. So we'll do a list of this, and I'll briefly go through his description because this is an excellent tutorial. 100, clears the screen, changes screen color to dark green, etc., etc. Line 110, now we look for joystick input and place -404 into C and R. Okay, remember here on this previous page, the second program demonstrates additive motion. The longer you hold the stick in one direction, the faster your sprite will move. So let's go into that. We'll run this. Alright, so I'll alpha lock off. Okay, as you can see, the longer I hold this, the faster the sprite is moving. And then it finally exceeds the limit and just starts over at 0 again. So let me slow that down a little. So the y -8, it's moving north at a speed of 8, and x is moving diagonal to the left at a speed of -4. So for me to go backwards, I have to hold the stick in the other direction. Hang on, I just rolled it off the bottom of the screen. Yeah, one thing he doesn't get into is that the bottom of the screen is a valid position for putting in sprites. And since it takes time to generate a sprite, there we go, 4 and -4, it'll move diagonally up to the right. Since it takes time to create a sprite in the first place, a lot of people will create them off the bottom of the screen, which is a valid screen position for sprites. And you'll notice as our sprite moves up off the top of the screen, it doesn't immediately show up at the bottom, because on the TI the screen is square, and there's a couple rows down there that you don't normally see. A little programming trick that's not used very much. So this shows you your additive motion in Joystick 2. And the third program we'll run moves the sprite to new graphic row or column. So we're going to quit this. Look at my notes. Go to caps. And it's not a TI program demo if everything works fine. Do a directory again of see if I typed in the right name. And the machine seems to be hanging up here. Okay, well that's not unusual. Shut down the console, shut down the compact flash. Reload the operating system. There we go. Okay. Yeah, I know if I can't catalog a disk with RXB's catalog program, then machine's messed up. Okay, but I could use the space bar to space down to page 10, program named Joystick 3. By pressing the space bar, RXB will load it. Okay, So now this says it'll move by columns and rows. Okay, we hit the limit. It won't let us go past the edge of the screen. So these would all be handy programs if you want to write a simple game. Okay, and that's joystick 3. And again, he explains every line, because these are multiple statement lines, what everything in there does it, and why he's doing it that way. Several times over the past few years, we've run a program called Miller's Graphics, which is a sequence of games. And you can load those games and you can list them, and you can see all this kind of stuff that he's doing on how he's written them. Catalog disk 1 again. Okay, now we're going to go to keyboard commands. Page 13, key 1. Okay, the following 3 programs were written to demonstrate different ways of moving your sprites around the screen with the keyboard. The first program sets your sprite in motion only when a key is pressed. Alright, so that's key 1 here. So yeah, just like the joystick one. So here, we'll just try north. And it tells you what key number it is and what your velocities are. Now we'll head it to the right, and you can see your X velocity. And it stops. And yeah, you can get a diagonal here, pressing Z. And again here, 100 clears the screen, sets a screen color, magnifies the sprite, and it creates your first sprite. Line 110 looks for a first we'll look for a key press on the left hand side of the keyboard and place its value in the variable K. And again, he goes through everything on what's going on that keyboard test program. Gotta have caps. Page 14, KEY2. Alright, see if I can load in the next program. We'll list that. The second program demonstrates additive motion. So these are just like the ones with the joystick, except you're using the keyboard. And we'll press the alpha lock off, press up. It shows how the velocity increases. Right now you probably can't even see the silly thing moving. It's just jumping around on the screen because it's faster. The motion's faster than this a combination I've got set up here on my VGA capture device. And here we can move it left and right. Move it to the left and stop it. Okay, the third program. To stop a sprite, you need to cancel out the motion it has. And then we have key 3. Okay, we'll list that out. Third program moves your sprite to new graphic row or column. So these show you the commands. I mean, you could just, lift the stuff directly and use these. And here we're using the keyboard. Where it moves it, there's no additive motion here, but if you try to go out of range, it won't let you. Alright, now we'll get into one of our favorite subjects, random numbers. See on my notes here, random, okay. We'll list this first. Okay, it doesn't look like much of a command, but wait a minute. Randomize and doing a call peak? What the heck is that? Well, the call peak command on the TI is really underused. Some people like with the Commodores, they're using call peaks, but they can also use a call poke to force a value into a particular location. So I don't think we can do that with the TI, but we can always do a call peek and look at something.
I don't remember what the extended basic equivalent of that is. I know the mini memory had some type of method for writing to areas of memory beyond the monitor for basic.
Yeah. The late Bruce Harrison was an expert on randomizing because he liked to program a clean card game where he said it's important to shuffle the cards, to really shuffle them, to have it truly be random, and then as you draw each card from the deck, to delete that from the stack. And no, he wasn't working with fourth. He meant like a stack of cards. And so I guess this will just run forever here. And I don't know if certain numbers get repeated or what. So, the statement is, listed below are 5 addresses you can peek into that return useful values for your program. So I'm going to quit this and list it. So this is 0 to 99 random numbers. All 5 of these addresses are located in a section of memory called the CPU RAM pad. This pad is located at addresses 33536 or hex 8300 through 33791 hex 83FF. To peek into an address higher than 32767, you must subtract 65536 from it. So our peekable CPU pad is located from negative 32000 through negative 31745.
Alright, so this is probably representing an absolute address, but you're dealing with BASIC, which uses floating point notation, so, or I shouldn't say floating point, signed values, so,
and you know the whole thing on the TI is doing a true randomize and then doing one where it always repeats certain patterns by using a seed number. The people who write maze games might want to have something randomized, but then if you want to play the same maze over again, they have to use a seed so they always get the same numbers.
Yeah, that's the problem with simplified algorithmic-based random number generators. Putting in the same seed results typically in the same sequence coming back out of it.
Yeah, and some people want a most definite randomization in there, so you can have your cake and eat it too. The description of this one-line program is you must execute a randomized statement prior to peeking into this address to obtain a random number. Generating random numbers through this address is much faster than the RND statement. The above program does not demonstrate the increased speed because it is slowed down by the print statement. There is an example at the end of this section that demonstrates the speed difference between RND and call peak random number generators. The other advantage to this menu is that it only generates integers between 0 and 99. So if you add 1 to it, it will generate integers between 1 and 100. All right. Going to our next program is the Vdp Interrupt Timer. It's 20, and the program name is Vdp Timer. This is a book that I had sorely wished came with a disc, because it has taken me, let's see, I bought this in 1984 when I was first able to get it, and it's taken me until last night to type all of these programs that are in this book onto this disc. I started it like in 1985, and I just finished last night. So this is one of those long-standing projects that's nice to finally finish. I will finish this project. So, here's the Vdp Interrupt Timer. This is address number 31879. The Video Display Processor Interrupt Timer. This address increments itself every 60th of a second and generates sequential integers from 0 through 255. So it's call peak negative 31879-A. This image should be clear enough so anybody can copy this at home and be able to do it. So I don't have to read along every single word on this. However, he does have a note for version 100 of Extended Basic. Change if A is less than 5, then, to if A is less than 7, then. So let's see now which one I have here. Print A. Call peak. If A is less than 5, then print. Colon, space, colon, A, semicolon, colon, colon. Okay, so we're going to see what version computer I have here. Because he talks about a TI-99, not a 4A in this book.
Yeah. Probably what was available to him at the time.
Uh-huh. Well, you remember he eventually wrote a disk editor that I used to recover a few disks where sector 1, where the directory
Yeah.
was blown, and things like that. He wrote the Explorer that lets you go through the TI startup one step at a time to see what's going on. Okay, let's list this. Alright, I feel playful. If A is less than 5, I'm going to deliberately change this to 7. Okay, he says to do that. He says this program was set up to skip a print line each time this address is read. The Vdp Interrupt Timer is reset every 4¼ seconds, which is 255 divided by 60 equals 4.25. Well, with all the print statements, you will find that it resets approximately every 4.8 seconds. Alright, next one is going to be the highest numbered sprite. Which is on page 22, which would be the Vdp status register. Vdp stats is 22 Vdp stats. Okay, so we'll go through this. This peekable address, -31877, this address is a copy of the Vdp status register. It contains information on sprite coincidence, and if there are more than 4 sprites in a row, it contains the number of the 5th invisible sprite. Well, that's going to be tough to do on this system because I have the F18 in here, and I have it set up for displaying 16 sprites on a line instead of just 4.
Mm-hmm.
So some of these sprites in a line demos aren't going to work. But then again, when I play a game like Burger Time, I don't have the evil hamburger ingredients blinking in and out of view as they all pile up on one line. So we'll see what happens here. Okay, like all registers, this register is made up of 8 bits or 1 byte. To obtain useful information from the status register, we need to know which bits are on, 1, and which ones are off, 0. The bits are numbered from 0 to 7 and correlate with binary positions that have set decimal values. So it shows like the bit number 0, 1, 2, 3, 4, 5, 6, 7, decimal value 128, 64, 32, 16, 8, 4, 2, and 0. Okay, bit number 0 is the 60 Hertz Vdp interval. Bit number 1 is on any time there are 5 or more sprites on the same row. Bit number 2 is on any time there is a sprite coincidence, the same as call coincidence all, C. Bits 3 through 7 will contain the number of the 5th sprite on a row when bit number 1 is on. And then there's the actual program here. Line 100 clears the screen, changes the screen color. Line 110 will loop here 8 times and set up sprite numbers 5, 6, 7, 8, 9, 10, 11, 12 as E, F, G, H, I, J, K, and L. These will generate the sprites at dot row 1 and dot column 140 with the row velocity, etc., etc. Line 120. Now our program will only loop through lines 120 and 130 First, we'll peek into the copy of the VDP status register and put its value in N. And then line 30, jump back to line 120 and do it all over again. There we go. So ABCD are 4 stationary sprites, and as that row descends, it tells you which one is the 5th on the line. To check for a sprite coincidence from this address, you will need to type in the following code in your programs. Call peak negative 31877, n, end parenthesis. If n and 32, then sprite coincidence has occurred. The code works the same as call coincidence all, n, if n, then sprite coincidence has occurred. Alright, moving along. We're going to go through 0 through 255 double random numbers. I typed in the wrong word, or wrong program name. Oh. Okay. Yeah, that's what I like about RxB. I can just find stuff here. Okay, so page 25, D for double, RNDM, random, and this is program A out of 2. Press the space bar, and it'll load it automatically and run it. So this gives you 2 double random numbers between 0 and 255. The program, the command is negative 31808. This is a 2-byte random number seed that generates 2 different random integers with values from 0 through 255. So we'll stop this, list it. Okay, not a very long program, is it? 100, randomize. You must execute a randomized statement prior to peeking into the address. So it's randomized, you do a call peek, but it pulls 2 values, A and B, then it says print A and B, then go to 100. So it just, goes back to itself. Alright, now we have a second one where he does this a little more complicated. We're still on page 25. DR and DM/B. I typed it in right. Okay, so we'll list this one out. Okay, so it starts out with call clear, call screen 7, call magnify 2, call sprite. Okay, that's like the standard setup he does. The following program will demonstrate the speed difference between random and call peek random number generators. When the program starts running, it will generate 2 random numbers using RND and relocate your sprite around the screen. After a short time, it will generate 2 random numbers using call peek, and you will be able to see how much faster your sprite is relocated. So line 100 clears the screen and sets everything up. Line 110, we will loop here 50 times. First, we will randomize to receive a true random number. This will define A as a random integer with a value between 0 and 255. It will define B as a random number with a value between 0 and 255. Now we will relocate our sprite to a new position according to the values of A and B. Okay. Line 120, after we have relocated our sprite 50 times, using the random statement, we will loop here 50 times. We must have a randomize here to obtain random numbers out of this address. Peek into negative 31808 and place two different random numbers into A and B. Relocate our sprite to a new position. Okay, I'll run it. Okay, that's using RND. Again, with the delay in the setup here using this VGA capture device, I don't know what you're actually going to see at home.
Yeah, it's going to be some variable, I imagine. I forget, did I miss what the actual, what that peak address is? What's actually providing the random number generation?
Yeah, I'll go through that. Gee, has it done it 50 times yet? Because it starts out with random, the random statement, and then it does the...
Right, the random function, the basic function, random number generation.
Yeah. I can't perceive any speed difference here, but then again, this is a very...
I think it changed, and I think it is slightly faster, but I probably have to... You probably have to run it again, and I probably have to actually pay closer attention. So my guess is the random number generator, the basic function random number generator is maybe slightly slower than whatever whatever memory location it's peaking into to pull its random numbers from.
Yeah, so here's line 100, sets up the screen. Line 110 for n equals 1 to 50, and using randomize, a equals the integer of random times 255. All right. Line 120 for line n equals 1 to 50, randomize, call peak. Okay, so the first 50 is randomized, and the second 50 are using the call peak.
Right.
Hang on, that's a TI demo until we... Okay, I have mistyped in this program because there's only a line 100, 110, and 120. There is no line 200. So let's do this again.
The reason why we're not perceiving any difference then, we may be missing some code.
Yeah, I must have had a page flip on me while I was typing this in.
And a line and omitted a line, right?
No, 2 extra lines. So we should have line 100, line 110, and line 120. Okay, that could be why it's confusing. Let's run it again. You know, if we added something like the screen changed color,
Right.
when it went from random to call peak.
Right. But, yeah, I mean, random number generation is largely an art form on computers. Who was it that said using math or
Oh, there it goes.
Great random numbers is in a state of sin?
Yeah, this is a faster one. Does it 50 times. Yeah, if I just put in like one command to change the color of the screen. Yeah, because line 100, call screen 7, then line 110, and then line 120. So I can add in here. I'll only run this once. Okay, if the screen's red, it's doing the, oh, and here the screen's blue, the faster one. But then it's going to go back to 110. Okay, I'll have to insert.
All right, worst case scenario, if you want to definitively know, insert a breakpoint between each ones and
Hang on, I got a misspelling here.
print something to the screen saying which, random number generator it's
Okay,
using.
well, if it's red, it's the random statement, and if it's blue, it's the call peak.
So there probably is a difference in speed, but it's not radically different. It's not like twice as fast.
No, you can't really perceive it on this system with this setup.
I can see, right, some of it I can kind of see a little bit, like I'll see things jump, but, you never know what the video encoder is doing.
Well, let me save this. What was that one called? Double random B. 25. I'll step over that one that was a mistake. All right. Not only is this random number generator considerably faster, it is also very useful for sprites, since it returns values that are within proper limits. The call peak negative 31808, comma AB, and call motion, parenthesis number 1, A minus 128, comma B negative minus 128, end parenthesis, will give you random sprite motion within the range of negative 128 to 127. As you see from some of the other examples in this book, it works quite well as a regular random number generator. Okay, now we're going to get into sprite patterns. Let me load in the next program, which will be on page 28, and its name is pattern 1. Pattern 1. Okay, we'll list it out. The following 3 sprite pattern programs are good examples of arithmetic progressions that can be generated in 4 next loops and applied to sprites with your TI 994 or 994A computer. Sprite pattern 1, that's what this one is, requires complete program control to be repetitive, but sprite patterns 2 and 3 are self-repetitive, and they will allow your computer to continue on with the rest of your program once they are generated. So call screen 2, A equals 1, line 110 for n equals 1 to 28. Call sprite number n, 61 plus A, 16, n times 6, 128 plus 65 times A, 031. All right, call sound, which is a negative number. Okay, line 110, we will loop this line 28 times to generate 28 sprites. Let's run it. Oh, okay. Yeah, we've seen a lot of demonstrations like this on Jim Peterson's Tiger Cub. Tips from the Tiger Cub and the nuts and bolts. So it generates repetitions of sprites with different locations. Okay, and here's the self-maintaining one. Call screen number 2 for n equals 1 to 28. Call sprite n 42, 16 n times 6, comma n times 2, comma 0 n times 4, colon colon, next n, and go to 110. Oh, okay. And this is always a good one, because they're traveling at different speeds, but after several screens, everything lines back up again. Here we go. And it starts over. Unlike sprite pattern 1, this program will only execute this line once. And it does. It's only one line of code running. Somewhere, someplace, I had a program that would look at a regular program, and it would do a trace for each line. But as you know, if you do trace with the TI, the screen scrolls up on you. You know, it's nice to try to determine what's going on, but you can't actually watch a running program using trace. Well, this one did, and it rewrote the program to put the trace line number, I think, in the lower right corner of the screen. And it took a long time to go through a basic or extended basic program. But once it did, it was sweet, because you could see what line number was executing what. Okay, we're not going to see it because it's black on white. So change your screen color. There we go. Alright, now you can see the trace command working there. It's just running line 110 over and over again. Okay, now we're going to go to pattern 3. On page 30. PATN 3. Alright, let's go back to the descriptions here. Sprite patterns 2 and 3 are self-repetitive. They allow your computer to continue on with the rest of your program once they are generated. Yeah, because that go to 110 only ever did go to 110. It didn't go back to 100 to start over again. Okay, so this is pattern 3. All right, let's run it. Oh, okay. So you got two intersecting patterns. and this will eventually straighten out. You'll have the two arcs starting from the outside of the screen going back to the inside. Like Sprite Pattern 2, this program will only execute this line once. First, we'll change the screen color to black. We set A equal to 1. We'll loop here and generate 28 sprites. Okay. Once again, this statement keeps our program running. Yeah, you got to have the program keep running somehow, so otherwise it'll reach the end of the line and stop. Again, we see the power of TI computers come shining through. What other home computer can accomplish all this in one line of code and keep running without any further program control?
Yeah, it's an interesting feature of the graphics on the TI.
Mm-hmm.
That it has somewhat of a motion control in the hardware itself too.
Yeah. I think I read once that the video chip in the 9940 here was originally designed for industry for a graphic display of control processes.
Yeah, that seems typical of a lot of the early microprocessor systems and the display technologies that went with them. That they had to have an industrial application for them, not just a home computer, not just a consumer. Otherwise, probably couldn't sell enough of them.
Oh, okay. Yeah, my notes are wrong. It's not chase 1, it's chase /1. Okay, what this will do, there are only two program statements required to set one sprite in motion towards another one. The first is called call position, which will return the position of both sprites. The second is called motion, with the simple formula in the row and column velocity parameters. The first program, this one we're watching, will generate two sprites on the screen and then randomly relocate sprite number 1 to a different position. It will find the position of sprites 1 and 2 and place number 2 in motion towards number 1. And if you've watched the Miller's Graphics 5-pack game programs, each one actually I should probably put that logo in here. Each one starts out with the Miller's Graphic logo and they come towards each other. The two letters M and G. So we have call clear, call screen, call magnify, call sprite. Then we have randomize. Here's your old friend call peek again. Call sound, call locate, and then you have your call position. And line 120 in the middle there, call motion number 2. Okay. Okay, so here's chase. Oh, so what we just did, we want chase number 2. Got to put the page number. So this program is very similar to sprite chase number 1, except in this one you're able to move the M sprite around with the number 1 joystick.
Mhm.
Okay, let me check the code here. Beautiful thing about this, when he printed this book, he formatted it. This is exactly what your code should look like when you list it on the TI.
Interesting.
It's not one of those where it's 80 column wide and you're sitting there going like, where did I make a mistake?
Yeah.
Because on this it's super easy. So let me go through editing this. Call clear, call screen 5, call magnify, call sprite number 1, 7716. Number 2 is 71. Okay, that gets us our MG. Go down a line here because that's not how it was supposed to work. Call joystick 1XY. Call motion number 1. 4 times negative y, comma, 4 times, oh, excuse me here. I got some, okay. Line 2, 4 times x. Okay, colon, colon, call position number 2, comma, r, comma, c, comma, number 1, comma, y, comma, x, colon, colon, call motion number 2, y minus r, times 0.49, x minus c, times 0.49, call coincidence all. Okay, line 120. If A, then call sound, negative 110, negative 28. Go to 110, else call sound, go to 110. I don't see an error where I typed in, but okay, you can't let the G catch you. So you got a rising pitch if you head up. Oh, it was written right, I just wasn't running it right. So here you've got a simple chase game. You're the M and the computer's the G. If the G catches the M, right, so I did type that in right. And that was chase number 2. Oh, now we have shooting. Again, Bruce Harrison was a master on the shooting. Where I don't know if you remember his Scud Busters. That was written after the Gulf War. Go ahead, James.
Oh, I wasn't really going to say anything. I was just kind of checking on something.
So the shooting, which is 35. We'll list it out. Okay, this is line 1, 2, 3. This is a 4-line program. And you know what? We're missing a line here. Alright, let me double check this. Call clear, call screen, call character, call sprite. Okay, line 110 for n equals 0 to 25. Randomize. Call pick, call sound. 8. Okay, 120, call position. Call sound. I'm missing a line. Okay. This is what happens when you let 25 years go between sequences on typing in a program. Nope. Ah! Butterfingers acted up again here. Call dull sprite number 1. Call sound 100 226. Next N. Go to 110.
Baron asks, could the problem be the alpha lock key?
Alright, let's try running this. Okay, what have we got for a bad value in number 1? Call clear, call screen, 2, call character, 46, 1, 818, quote, parenthesis, colon, call sprite, number 2, 94, 16, 180, 105. Okay. Boy, this looks awful suspicious. Try editing this line. Once before I okay, do I have a 0 instead of a... Yeah, sure as heck do. I got a bunch of O's here instead of zeros. Try running that. Syntax error. Okay, in 120. Call position 3. Oh, missing a comma. Even I can see that from here. Okay, this shows an automated targeting system to where no matter where the alphabetical letter is, the carrot is able to fire a projectile in that direction to intercept. This is how to shoot sprites without missing a coincidence. As you type in this program, you'll notice the call coincidence program was not used. The theory of operation behind this program is similar to the sprite chase program, and that to and from times 0.49 formula was used to set our sprite in motion. As you notice in this example program, we never miss our target. You can change this by adding some additional code to check the distance between the sprites, and if your sprites are in range, then allow a hit, and if it's not in range, then delete it short of your target. Yeah, so you only have so much fuel or whatever to have your interceptor reach. The time delay between generating your sprite and deleting it can be used to display your score, or to add counters, or to test to see if you should allow a hit or whatever. So with a little additional logic added, you can have a lot of control and never miss a coincidence.
No.
Now we're going to go to picking up stuff. Okay, now we're going to do the same thing, but I think we're going to have joystick control. Listed below are the program lines that may be changed to incorporate joysticks in the shooting program. So if you look at the line numbers here, I mean, we start with line 100, but then it adds in line 115, 116, and line 120 to the previous program. Okay, let's see where I made a mistake here. Joystick 1XY, call motion number 2 0 x times 3. Oh, ruh-roh. Call key. Something still ain't right because this doesn't. The second line there doesn't match up with what's printed in the book. Call motion number 2 0 x times 3 end parenthesis colon call key. You might say, Vic, didn't you bother testing these programs? No, I just recently finished typing these in out of the book. And so you're seeing me testing them now.
Debug in real time.
Yes, call. Okay, I think I see the problem, although it's not really apparent. It's call.
Defeat the meter.
Yeah. It's time for me to... Hello? Oh, hell? Yeah, it's nice to hear you.
Okay, I was wondering, there must be a kind of a delay on what I'm seeing on the screen. I was going to offer a suggestion, but I think you probably already found it by now.
Well, go ahead.
On the program you were running on
Sorry for the brief pause, people. Sounds like Hal is called in and is talking to Vic right now, so probably get a report shortly thereafter.
so you can pick up the phone, so.
Oh, okay.
Yeah, okay, well, I think you've already found the answer. Not that I'm a great spotter, but there was an extra letter or something in there.
Yeah, it doesn't match up with the printout in the book. I got Hal Shanafield on the phone. Say hi to everybody, Hal.
Hey everybody, sorry I couldn't, the first 15 minutes of the show I missed because I was trying to get into the program here, and Google, as usual, was keeping me out for some damn reason, and I don't know why, but we will have to figure that out at some point or another. This doesn't match up with the printout of the book. I got Hal Shanafield on the phone. Say hi to everybody, Hal.
Too many audio sources.
I believe Hal is talking to Almut right now, and he's not really intending to be on the air.
Yeah, it's a little difficult when I'm watching, and there's quite a delay in the thing. But listen, go on back and finish the show. You're doing great, and I'm learning more than I've learned in the last 30 years or so. Your efforts of 37 years of typing these things in is paying off. Okay. Watching, and there's quite a delay. Okay, but let's go on back and finish the show. You're doing great, and I'm learning more than I've learned in the last 30 years or so. Your efforts of 37 years of typing these things in is paying off. All right.
I think I found the error in line 116 here. Is I have two closing
I thought
parentheses.
I turned this thing off. All right, I don't want to interrupt the show, so listen, I'll call you back after the show.
Okay, sounds good.
Oh, you call me? No. I thought it. I think I found the error.
Okay, I see here that Craig has maxed out the 5-line limit. And when I re-edited line 115, it was too long. So I didn't get the trailing 0 here on line 115. Ah, here we go. Okay. So this seems to be, you can control the caret at the bottom, and when you press the fire button, you unleash a missile that, oh God, subprogram not one, call Sprite. Okay, this appears that the caret symbol at the bottom of the screen has moved left and right, but not up or down. And you try to get positioned under the letter, press the fire button, and it went everywhere except where I wanted it to. Line 120, call sprite number 14616RC, comma, parenthesis, y minus r, end parenthesis, times 0.49, comma, x minus c times 0.49, call sound 476, negative 314. That looks good to me. Bad value, okay. Call sprite number 1, comma, 46, comma, 16, commas, r, comma, c, comma, parenthesis, y minus r, end parenthesis, times 0.49, comma, parenthesis, x minus c, end parenthesis. Oh! Okay. Supposed to be an end parenthesis here.
Close parenthesis.
X minus c, and then yeah, I just deleted line 120. Okay.
Well, then there's also a comma there in some other parenthesis groupings. So
Yeah.
maybe we're missing one on the far right.
So I said this is nice where the formatting in the book matches what you should see on the screen. Whoops. That'll give us a bad, weird value if we do that. So R times 0.49, comma, x minus c. Okay, here's where I made a mistake. Times point 49. Yeah, I missed that times symbol. Times 0.49, end parenthesis, colon. Let's try running it. Alright. Okay, so this does the simple task of firing vertically from your movable position on the bottom. Okay. That's how I use the joystick to to, here, let me get on screen here. So use the joystick to move that bottom character. And you have a target that appears in a random position on the screen. But you can't move your gun. Okay. So that's the Joy Shoot.
For your SD invaders, Dave.
Mm-hmm. Yes. And then on page 40 here, we have a pickup. And let me get to his notes. This example will combine together some of the items from previous sections to demonstrate how to make your sprite pick up and put down objects on the screen. Oh, sound familiar, like Pac-Man or Munchman? In the first example, your sprite will be placed in motion according to input from the number 1 joystick. The program will then check its position and place a red block underneath it. All right. So we got pickup number 1. So we listed it out here. So line 100 clears the screen, sets a screen color, draws stuff, and it sets up the field. And now line 110, now that everything is set up, we will only loop through lines 110, 120, and 130. We'll look for a joystick input. Okay. Well, let's try running it. Okay, so line 120 is call G character integer parenthesis parenthesis r plus 7 end parenthesis divided by 8. Wait a minute. Line 120 divided by 8, comma. Okay, a second line, integer, parenthesis, parenthesis, x plus 7, end parenthesis, divided by 8, end parenthesis, comma, y, colon, colon. If y equals 32, then call sound, parenthesis, negative 90, 660, comma, 9, end parenthesis, colon, colon. Call H character, parenthesis, int, parenthesis, parenthesis, r plus 7, end parenthesis, divided by 8, end parenthesis, comma, integer, colon, colon, x plus 7, end parenthesis. Looks like I got an extra space there after 7. Divided by 7 and closing parenthesis. I got a K there. I got my butterfingers. Doesn't belong there in that 4th line. Or 5th line rather there. End parenthesis 7 end parenthesis divided by 8 end parenthesis comma 40. Okay. Let's try running it. The heck? Thought I got that. X plus 7 colon divided by 8 comma 40. Okay, call G character, G char, parenthesis int, parenth, r plus 7, end parenth, divided by 8, end parenth, comma, line 2, int, parenth, x plus 7, end parenth, divided by 8, end parenth, comma, y, colon, if y equals 32, then call sound, parenth, negative
Missing
90,
the,
comma,
parenthesis
660,
penalty
comma,
at the very
9.
end of that statement.
Huh?
Are we missing the trailing GCAR parenthesis grouping?
Integer x plus 7 end parenthesis. Now let's call gcar parenthesis int parenth r plus 7 end parenth divided by 8 end parenth. Yeah, there seems to be an extra one there. Let me see it. Call gcar parenth int parenth r plus 7 end parenth divided by 8 comma. That line is the way it's written in the book. Hello? Yeah, I think so. It might be a typographical error in the program listing itself. I'm trying to very carefully go through this. So there's that one there, there's that one there, and there's that one there. No, there's 1, 2, 3 on the left and 1, 2 on the right. Okay, this might be a typographical error in the book. I'll try deleting that and running it. No. Syntax error on line 120. Begin, end, end. Begin, end. Ooh, the second line has a line 120. One parenthesis to open, parenthesis integer, parenthesis r plus 7, end parenthesis divided by 8, end parenthesis.
We're missing an end parenthesis off of the last GCAR line. Like, it almost seems like he was doing something to exploit an earlier version of BASIC or something. Like, if it was missing the last parenthesis, it wouldn't bother, it would just assume close.
Finally got you, Mr. Miller.
Is that an extra parenthesis after the, extra space after the 8?
So we have here integer parenthesis x minus 7 closing parenthesis y. Okay, shows a closing parenthesis here after this y, but we don't have a leading parenthesis. Yeah, because up in this line, this first G character, he shows one parenthesis leading, int, and then at the position that my cursor is at, 2 leading parentheses. But then we have one closing, two closing. So we couldn't have three leading parentheses at this statement, this line, because there's only two closing ones. And then there's a comma here. So can you have parentheses include stuff that's separated by a comma? Yeah, because to do this per the book, will you quit integer parenth r plus 7 r
Well, at least you know it's a TI demo.
r plus 7 yeah, end parenthesis divided by 8 comma. Okay, I still don't have this line. This line does not match up with the book. I'm getting confused here. Call G character parent init parenth r plus 7 end parenth divided by 8 comma. No, it's not matching how it's printed out in the book. I gotta figure out what I'm doing wrong here. 120. Call G character parenth init parenth r plus 7 end parenth divided by 8 comma, and then it's supposed to go to the next line. So I'm missing a character here in line 120 somehow now. And I don't understand how that can be. Okay, I'll just list it out. Okay, call G char parenth int two leading parentheses. Okay, that's where I was getting mixed up here. Insert. Okay, now it matches what's in the book. Two leading parentheses, r plus 7, end parenthesis, divided by 8, end parenthesis, comma. I'm just not used to a parenthesis being able to span two statements with a comma, but I'll put it back in. Okay. So this matches what's in the book. The last symbol on this line is a comma. Then int double parenth x plus 7 end parenth divided by 8 end parenth comma y end parenth. That's exactly how it's written here in the book. Okay.
I didn't see any comma y. Oh, I'm on the wrong line.
Okay. So, yeah, well, that's how it's written in the book. So this would need some debugging. There's either... yeah, every other statement that has a parenthesis in it, it's not separated by a comma from another...
Ricky Barron is saying you're missing the last closing bracket parenthesis for the call hchar statement.
Yeah. Yeah, because it starts out here at the beginning of line 120. Here's the first leading parenthesis, second leading, third leading, first closing, second closing, comma. then an opening, a closing, a comma, and then here's our third.
You've got 3 closing parentheses, only 2 opening parentheses in the second line. It's paren, x plus 7, closing paren, divided by 8, closing paren, comma, y, closing paren, and there's no opening paren before the y. Or you already used up the two opening parens. Does that make sense?
Yes, it does, Hal.
I'm watching this on a 55-inch screen, so it's really big, and I can probably see it better than you can.
Yeah, it's just it's a bit of a puzzle. This is the first line has 3 opening parentheses and 2 closing. The second line has 2 opening and 3 closings.
Oh, I see. Yeah, okay.
So I'm just not used to a parenthesis spanning a comma like that.
But I think Ricky Barron is correct on chat that each per line is missing a parenthesis.
Question for you. I've noticed that after a parenthesis, after a closing parenthesis, there's no space between a double colon. Should there be a space in there?
Yeah, I can put a space there, but then the editor will automatically close it up. Like here, I'll deliberately use a function number 2 for insert and put a space there. Then I'll press enter. Now we'll do a 120 again. And you see how it's closed it up.
Yeah,
Okay, it takes a couple
weird
seconds for
parsing
there's a
behavior.
little delay. It takes 10 or 15 seconds for what I see on the screen.
Yeah, so there's 3 opening
What'd you say?
on line 1 and 2 closing, and then 2 opening on the second line here, and 1, 2.
Can you try what he was suggesting and putting that?
Okay. Now I see
Maybe
the
it's
space
framing.
that you put in there. And before the double parentheses, or double colon, I mean. And
Yeah, I did that. If you look at the line above the 1 the cursor is on, they're identical except the top line 120 has a space between the Y and trailing parenthesis and double colon. I entered that line, and then when I relisted it, it closed it up.
yeah, I wonder if you ran it before you listed. That would take that out. I don't know.
Yeah, it's a bit of a puzzle for me.
I guess Vic isn't hearing me.
I can hear you, James.
Okay, well, listen, we've got a suggestion of where the problem is. If you go towards the second to last line, the H car call, I think the parentheses are not balanced correctly. I think we've got 3 opening and 2 closing in that statement, so it may need another one on the end.
Okay.
Or at least somewhere in that statement group.
Well, I can see there is a difference between this and the book because there's a closing 1 here. So I'll put a closing 1 there. Shift and 0. Enter. Save our work. Ah, it's not crashing. So what were we supposed to do with this? Another exciting, thrill-packed action adventures. Alright. the first example, your sprite will be placed in motion according to the input from the number 1 joystick. Okay. Okay, it only makes a sound if it's drawing. Okay, so that's pickup number 1, or addendum.
What I do with those seeds.
I give my wife back the phone. I'll call you later.
Okay. Alright, so that was pickup number 1 operating correctly. I'll load the next one. Okay, so here's pickup number 2. Let's go back to our notes here. In the first example, your sprite will be placed in motion according to the input from number 1 joystick. Program will check its position and place a red block underneath it. Okay, it did that. Second program will generate a screen with the alphabet characters randomly placed on it. Then when you move your sprite around with the number 1 joystick, you can pick up 1 letter. The letter your sprite is holding will be displayed in the upper left-hand corner of the screen. To get your sprite to put the letter down, you must place it in the proper alphabetical order in one of the boxes at the top of the screen. If you do not have joysticks, you can insert the code needed from the call key examples in this book in place of the call joystick code. So here's pickup number 2. Well, this is becoming routine now. Call H character 24 140. Okay, that's pretty obvious there. No closing parenthesis. Okay, then call V character 130 140 96 and parenthesis. Call H character 25 33 26 closing parenthesis colon. Call sprite parenthesis number 134 217 closing. Okay. Save it and try running it. Okay, great. Alright, we're going to try this one. I think, alright, we picked up A. And he automatically picked it up when he was over. So that shows, got letter P. Okay, I picked up the wrong letter. So okay, then when you're in the right position, so you don't really have to pick them up in sequence, because here, I'll pick this one up Okay, I picked up the letter T, as you can see in the upper left-hand corner. And I get a beeping sound until I got the little man, the QRS, till I got him in the right position. Okay. He's got a couple alphabets here, so. Alright. So this would be a, could form the basis of a child's learning the alphabet game. You get an error code if you're on top of a wrong letter. Okay, yeah, so this pickup one shows that I think he's written this kind of program too. Where you have letters scattered around the screen and you have to pick them up and put them in sequence. Okay, one more is a Dotson Trail. So. Let me save that. List it. Okay, so in dots here, this program will set up a sprite that eats dots as you move it around with the number 1 joystick. It will also lay down a blue wall trail behind your sprite, open and close its mouth, and change its pattern to correlate with the direction it is headed in. The second program will generate a maze on the screen that you move around. Okay, I think this is as far as I've gotten, and I've only got dots in. So let's try running it. Bad value in 130, might not be in 130, it might be an error in a previous line. But anyway, for R equals 1 to 50, randomize call peak negative 31808 comma x comma y end parenthesis colon colon call h character parenthesis integer parenthesis x minus 12. That's supposed to be an x divided by 12. So that'll give us a x divided by 12 plus 2, comma, integer y divided by 10, end parenthesis, plus 4, 33, end parenthesis, colon, colon, next r, colon, colon, r, comma, c, minus 3. Okay. Oh, there we go. I think he... Oof.
Oh boy.
Call pattern number 1, P, end parenthesis. Call locate, parenthesis, number 1. Well, there's probably supposed to be a comma there. Yeah, I think he did a program called Alphabet Soup. Okay, here's our, oh, you can't go back over your previous trail. That's a surprise. Alright, so in this one you can really box yourself in. Because you can't backtrack. Yeah, I think you did a children's education one called Alphabet Soup. And this on-screen character was called Super Cracker, spelled S-O-U-P. Alright, so that was Chase the Dots. Alright, well that's, there are like 4 more programs in this book that I haven't typed in. The maze puzzle one, and bar graphing, and that's it. There's 2 more that 3 more. General bar grapher, and an enhanced one. Again, this book is available on the ChicagoTIUG user group Facebook page. There's a link to it there, and I'll see if I can put a link up on this YouTube channel if I'm able to do that for this book, and maybe I'll see if I can upload this disk of programs so you don't have to type in all these programs and make all the mistakes that I did. Oop. Let me save our work here. Okay, and then for fun, I'll give you a preview of what might be coming next month is the Miller Graphics Night Mission program. And what's fun about this is it's a tutorial. Moment. Night Mission came with a real nice booklet, the same size and shape as a smart programming guide. And wouldn't you know, a Night Mission, this is a tutorial of how to play the game and also how the game is programmed. And it goes through darn near every line of code describing what's going on and what it's doing. And it's the most fascinating book and program too. So let's say we want to use the #1 joystick here for the Night Mission. We'll press okay, by Mike McHugh and Craig Miller. So it's nighttime, there's the moon, there's the stars, there's our chopper. There's the terrain. So you're flying your helicopter over the terrain. And you get shot at by the tank. But you can fly backwards. What you have to do is try to pick up that soldier before the tank machine guns your helicopter or shoots you out of the sky. You can do everything except hover with this machine. So I found the best chance you have is fly off one side of the screen, land, and then take off quickly before that pesky pesky tank gets to you, because he has to traverse the screen. And the tank blew up the helicopter. So let's do a list, and this is all in extended basic, but you can probably recognize them. Still listing. Oh, here we go. Line 10 sort of looks familiar to what we've been working through on the Smart Programming Guide for Sprites. Is call magnify, call screen, links you to another line. Now to make the program run faster, he does all his initialization. He calls stuff before you actually start playing the program for the first time. So call key, call joystick, call sound, call peak, call H character. Those are all the different commands. You call them at the beginning of the program, and the program will run faster. And so you saw there was a bit of an initialize time in there on getting everything up and running. But yeah, call position, call pattern, call sprite, call del sprite, call coincidence, call motion, call locate. All that stuff's at the beginning of the program. So then again, here it is. That's what we're going to be doing next month. Is I'll have the last two programs on the Smart Programming Guide with the bar graphing program. Oh, the maze program. We did the pick up the dots. The one after that, it draws a maze. And then the one after that's a bar graph. And then we'll go through the night mission. So, let's get my
Closing.
binders work good. Here's the original. See if I can get a good picture of this. Here's the original night mission floppy disk, and here's the ad for it out of the catalog. It's probably out of focus, but the ad for it that I answered, I cut that catalog apart and I pasted the individual ads in these folders or binders or on the floppy disks as a reminder of what it was I bought, so I don't confuse later on going, oh, I thought you could do this with this program, and it turns out, no, that's another program you can do that with. And then we did demonstrate the Miller's Graphics, the MG games, where you have Blackbeard's Treasure, The Pharaoh's Tomb, Crazy Funhouse, Casino Blackjack, and Attack Over Titan. We've done Blackbeard's Treasure a few times, and that shows you the additive motion of the joysticks as you're controlling your diver as he descends into the ocean or he ascends back up again. But that's about it for this month. We've run quite a long time here. So I'm going to say good night.
Okay. So once again, this has been the ChicagoTIUG 99 Users Group meeting, the May 2022 meeting. I think we have, one more meeting in the pipeline before we take our summer break. And somewhere in there we will probably have a group picnic if all is good. And then once again, I will remind everyone that currently I believe the date for the fair is October 29th, which is the last Saturday in October. This has been called angrily incorrect if I'm wrong. Or if he doesn't want to publish that information. think that's going to likely be the case. Unless, of course, something unpredictable happens.
Yes. As you see, other family members in our various families seem to want to schedule stuff for the first Saturday of the month. And, you know, pesky things like wedding anniversaries and birthdays and things like that, and they just don't want to schedule them.
Yeah,
The
I know
second-
we've been having first
just-
Saturday alignment problems
Yeah.
lately. But I mean, you know, since we're doing meetings virtual at the moment, I don't think it really matters that much.
So, but we do our best to get everything done here. I hope this wasn't too tedious. You know, rather than watching somebody play games for a while, this is how the games are written. And having tight code at the beginning, like some of Craig Miller's algorithms, I don't know how he figured them out. He's smart. And yeah, some of those algorithms are pretty complex, but boy, if you can get most of your code into multiple statement lines, and each statement is interpreted one line at a or every line is interpreted separately, so the more statements you can put in a line, the faster it'll run. Then he had his math for combining stuff, where you do 2 or 3 different things in a line. But yeah, that's it for this month, and we'll see you again next month.
All right,
Let's
thanks.
look at a calendar and see when next month is. I got the 4th of June would be the next Saturday, first Saturday of the month. So I can't think of anything that's going on unless we got, is there a Memorial Day weekend there, or Labor Day or something like that? We'll shoot for the 4th of next month.